Hello everyone, and welcome to today's presentation. I'm excited to have you here. We're going to explore a very important topic, real-world IT. Specifically, we'll be focusing on identity attacks and credential theft within Active Directory and Windows environments. Throughout this session, we'll look at real-world examples, understand how these attacks happen, and discuss ways to protect your systems. So, let's get started and dive into this crucial subject together. Let's take a closer look at the attack and defense flow. The process often starts with phishing, which aims to steal credentials. Once attackers have those credentials, they can move laterally within the network, gaining access to more systems. This can eventually lead to a domain compromise, giving them control over the entire environment. Now, when it comes to defending against this, the key is to focus on identity hardening. That means reducing credential exposure and making it harder for attackers to steal and use those credentials. Remember, in today's threat landscape, identity is often the primary target because once they have it, attackers can do a lot more damage. It's important to understand why this matters. Credentials can bypass most traditional controls, like firewalls or perimeter defenses. So, even if your perimeter is strong, stolen identities can walk right in and move silently through your network. This brings us to a common misconception. Many believe firewalls can stop attackers. But the reality is, stolen identities can easily bypass these defenses. They don't need to breach the perimeter anymore. They just walk in through compromised credentials. So the core message here is that identity is really the new perimeter. Protecting identities isn't just a good idea. It's essential for defending your entire enterprise. Let's take a closer look at the attack and defense flow here. It all begins with initial access, where an attacker gains entry into the system. From there, they often move on to dump credentials, extracting sensitive information like passwords. Once they have those credentials, reuse becomes possible, allowing them to access other parts of the network without needing to re-exploit vulnerabilities. After that, escalation is the final step, where they elevate their privileges to gain full control. Now, on the defense side, the key is to map these identity flows carefully. We need to understand how each stage connects and intervene early. Protecting each stage is crucial because identity attacks tend to follow predictable patterns. Knowing these stages helps us anticipate and block them effectively. Remember, the typical enterprise impact of these attacks can be quite severe. Rapid takeover of critical systems and data. A common failure we see is the lack of proper identity monitoring, which leaves organizations blind to ongoing malicious activity. To break this cycle, our main strategy should be to disrupt the reuse paths, making it harder for attackers to leverage stolen credentials across different systems. This entire lifecycle highlights the importance of comprehensive identity security measures to defend against credential theft and lateral movement. Let's take a closer look at the attack and defense flow involving LSASS. When an attacker gains access, they often target LSASS to extract hashes, which they can then use to authenticate elsewhere in the network. This process is a key part of lateral movement strategies. Now, in terms of how to defend against this, one important step is to audit NTLM usage across your environment. Identifying where NTLM is still in use helps you understand your attack surface. Then, you should restrict NTLM via group policy to limit its exposure. A critical point here is pass the hash, or PTH. Attackers leverage NTLM hashes instead of plain passwords. The reason this works so well for them is that hashes are reusable. If they capture a hash, they can reuse it on other systems without needing the actual password. This has a significant enterprise impact because it enables lateral admin access. Once an attacker has a single hash, they can move across systems more easily, escalating their privileges. One common gap in defenses is that NTLM is often still used everywhere. It's deeply embedded in many environments. To improve security, the best approach is to reduce NTLM usage as much as possible. By doing so, you effectively cut down on the attack vectors that rely on hash reuse. making it harder for attackers to leverage PTH techniques against your organization. Let's take a look at the attack and defense flow related to NTLM authentication. When NTLM is used, it can often be blocked, especially since it is considered legacy and risky. In contrast, Kerberos is the preferred authentication method because it is more secure. Now, moving on to the how-to, or commands section, it's important to start by configuring group policy to restrict NTLM, specifically by auditing its use first. You want to review event logs to see where NTLM is still being used. Remember, NTLM is outdated and poses security risks because it can enable pass-the-hash attacks, which allow attackers to impersonate users more easily. The impact on the enterprise can be significant, since NTLM can spread malware or lateral movement across systems quite easily. That's why the approach should be gradual. First audit, then implement restrictions, and finally enforce blocking. The key is to audit NTLM usage thoroughly before you block it entirely. This helps prevent disruptions and gives you a clear picture of where NTLM is still in use. Over time, you can move toward gradually enforcing restrictions, ultimately restricting NTLM authentication to improve your overall security posture. Let's take a closer look at the attack and defense flow involving TGT and TGS. These are key components in Kerberos authentication. Attackers often aim to reuse these tickets to gain access or move laterally within a network. Reusing tickets can allow them to authenticate without needing a password, which makes detection more challenging. On the defense side, a critical step is to enable LSASS protection. LSASS is the process that handles Kerberos tickets, so protecting it helps prevent attackers from extracting or manipulating these tickets. Limiting administrative logons also reduces the risk, since fewer accounts have the privileges needed to misuse tickets. Now, how do attackers exploit this? They take advantage of the fact that Kerberos tickets can be reused, especially if they are stored on endpoints, which is a common gap in many environments. This reuse allows stealthy access without triggering typical password-based defenses. An important point to remember is that Kerberos tickets can be reused because they don't require the password again once issued. That's why protecting these tickets and the process that handles them is so vital. This leads us to the pass-the-ticket attack, or PTT. In this scenario, attackers steal a valid ticket and reuse it to impersonate a user on the network. By doing so, they can bypass many traditional security controls and move laterally undetected. In summary, understanding how tickets are reused and implementing defenses like LSASS protection are essential to defending against these stealthy attacks. Recognizing these flow patterns helps us better secure our environments against evolving threats. Let's take a closer look at the attack and defense flow related to malware, specifically focusing on LSASS access. When an attacker tries to access LSASS, it often indicates an attempt to dump credentials from memory. To mitigate this, one effective measure is to configure the registry setting run as PPL equals 1, which enforces protected process light mode through group policy. This makes it much harder for malicious tools to access LSASS. Now, why does this matter? Because LSASS stores credentials in memory, making it a prime target for dump tools used by attackers to steal credentials. The impact on the enterprise can be significant, as credential theft can lead to lateral movement, privilege escalation, and ultimately, a breach. To defend against this, we recommend enabling Run as PPL. This protection stops common credential dumping tools in their tracks by restricting access to LSASS. Overall, implementing these protections enhances our security posture by safeguarding sensitive credential information against malicious exploitation. Let's walk through the attack and defense flow related to service tickets. When an attacker gains access, they can exploit a service ticket, leading to a crack and potentially gaining admin access. Now, to understand how attackers do this, we look at some common techniques and commands. One key method is auditing SBNs, service principal names, to identify vulnerabilities. Additionally, using GMSA, or Group Managed Service Accounts, significantly improves security because they help mitigate these risks. Service accounts often expose SBNs, which can be exploited by attackers. This matters because it enables offline cracking of passwords, making it easier for attackers to escalate their privileges within the enterprise. A common issue here is weak service account passwords, which makes this process even more vulnerable. To defend against this, adopting GMSA is highly recommended, as it reduces the attack surface. One specific attack technique we see is Kerber roasting, where attackers request service tickets for service accounts and then crack them offline. Understanding these attack flows helps us better prepare and implement effective defenses. Let's talk about the attack and defense flow here. It all starts with captured authentication, which can then be relayed to gain access. This relay process allows an attacker to forward authentication sessions and potentially access systems without cracking passwords. To defend against this, the key measures are enabling SMB signing and LDAP signing. These protocols ensure that the authentication messages are signed, making relay attacks much harder. Why does this matter? Because it eliminates the need for cracking passwords, which can be time-consuming and complex. Instead, attackers can quickly compromise systems through relayed sessions if these signing protections aren't in place. A common gap we see is the use of unsigned protocols, leaving systems vulnerable. The best defense is to implement signing on all protocols that support it. Specifically, NTLM relay attacks are a significant threat, as they exploit these unsigned protocols to relay authentication credentials. By understanding this flow and applying the right defenses, we can greatly reduce the risk of such attacks and improve our overall security posture. All right, let's take a closer look at the attack/defense flow here. When it comes to secrets, they are isolated using a technology called Credential Guard, which is essential for protecting high-value controls in our environment. You can enable this feature through group policy or in Tune, making deployment straightforward across your organization. A key step is to verify that virtualization-based security, or VBS, is enabled. This is crucial because Credential Guard relies on VBS to isolate secrets effectively. Think of it as creating a secure vault that even malware with administrative privileges can't access. Why does this matter? Because even if malware manages to run with admin rights, it won't be able to dump or steal those secrets. This significantly raises the bar for attackers and adds a robust layer of defense. From an enterprise perspective, this technology helps stop credential dumping attacks, which are a common way attackers escalate privileges or move laterally within networks. The main requirement here is VBS. Without it, Credential Guard can't function. So, enabling VBS is a vital step to protecting your most sensitive credentials and maintaining control over high-value assets in your organization. Let's take a closer look at the attack and defense flow across different tiers. Starting with Tier 0, this is where your most critical assets and credentials reside. Moving to Tier 1, it typically involves key systems that support the core infrastructure, and then Tier 2 covers the broader environment, like user workstations and peripheral systems. Now, in terms of how to manage this, there are some key commands or practices to keep in mind. First, creating separate admin accounts for different tiers is essential. This means not using the same admin account across all levels, which helps contain potential breaches. Second, restricting logons, ensuring that admin accounts can only log onto specific systems, reduces the attack surface. It's important to recognize that admin accounts are high-risk assets because if compromised, they can lead to total takeover of your environment. That's why credential exposure is such a big concern. The more credentials are stored or accessible across various tiers, the easier it becomes for an attacker to move laterally. This leads us to the concept of tier separation, limiting where credentials exist and ensuring they are only available in their designated tiers. A tiered admin model enforces this separation, helping to contain any potential damage and making it harder for attackers to escalate privileges. Overall, implementing these controls strengthens your defense, making it much more difficult for an attacker to move from one tier to another and helping protect your entire enterprise. Let's take a closer look at the attack and defense flow when it comes to workstations. One key aspect is the admin logon process. It's crucial to deny logons locally on workstations and also restrict RDP access. Why? Because when admins log into endpoints, their credentials are exposed, which significantly increases the risk of credential dumping. This is important because credential dumps can lead to escalation within the enterprise, giving attackers broader access. To defend against this, implementing logon restrictions is essential. Using group policy enforcement to restrict admin logon locations helps ensure admins can only log onto approved devices or from trusted locations. By doing so, we minimize the attack surface and reduce the likelihood of credential theft. Overall, restricting admin logon options is a vital part of our defense strategy to protect enterprise assets and maintain security integrity. Let's walk through the attack and defense flow between machine A and machine B on the attack side. An attacker might start by enabling Windows Local Administrator Password Solution, or LAPS, on a machine. Once enabled, they can verify the rotation of the passwords, which means they can see how often these passwords change. Shared local admin passwords are a big concern because they enable the attacker to spread laterally across multiple machines. If the same password is reused, it makes it much easier for an attacker to pivot from one system to another. Now, why does this matter? Well, an attacker can leverage this shared password to quickly move through the network, gaining access to multiple systems without much effort. This rapid pivoting can lead to widespread infection within an organization. From a defense perspective, the key solution is implementing Windows LAPS. By ensuring that each machine has a unique, automatically rotated local administrator password, we significantly reduce the risk of lateral movement. Unique passwords make it much harder for an attacker to reuse credentials across devices, thereby strengthening our overall security posture. Now let's take a closer look at the attack and defense flow, starting with authentication logs. When we see suspicious activity, the first step is to investigate these logs to understand what's happening behind the scenes. Monitoring security logs is crucial. By keeping an eye on them, we can spot unusual spikes that might indicate an attack. Identity abuse often leaves traces in these logs, which makes early detection possible and vital. Catching these signs early can prevent further damage. Key events to watch for include event IDs 4624 and 4769, which are critical indicators of authentication processes and potential anomalies. It's also important to look for any irregular patterns or anomalies in these logs that could suggest malicious activity. Centralizing logs from various sources helps us get a comprehensive view, making it easier to identify and respond to threats quickly. Finally, identity monitoring signals. These are the indicators that alert us to suspicious or abnormal behavior, giving us the opportunity to act before an attacker can do more harm. So, in summary, by thoroughly monitoring logs, focusing on key events, and looking for anomalies, we can build a strong defense against identity-based attacks. Let's walk through the attack and defense flow outlined here. When an incident occurs, the key is to learn from it, identify what went wrong, and implement fixes accordingly. This cycle helps us strengthen our security posture over time. Now, in terms of how to defend, one of the most effective strategies is to harden service accounts. That means securing them properly to prevent misuse. Additionally, restricting admin usage limits the potential damage if credentials are compromised. Speaking of attacks, a common sequence involves phishing leading to Kerber roasting, which can then escalate to domain admin privileges. If we fail to secure our accounts, say, by using weak service accounts, attackers can gain full domain control, which is a critical risk. To prevent this, we can implement measures like GMSA or group managed service accounts, and enhance LSASS protection to make credential theft much harder. This slide also emphasizes lessons learned from incidents like credential theft. Understanding these patterns allows us to better anticipate and prevent future attacks. In the example of credential theft, the attacker's goal is to steal credentials, but with the right defenses, like strong account security and proactive monitoring, we can disrupt this flow before it escalates to a full compromise. Let's take a closer look at the attack/defense flow checklist. The main goal here is to reduce risk by implementing effective security measures. To do that, we need to review our controls regularly, ideally on a quarterly basis, so we stay ahead of emerging threats. Testing these controls is equally important. We want to make sure they're working as intended before an attacker can exploit them. One key step is reducing NTLM usage, since it's a common target for attackers, and implementing measures to protect LSASS, which is critical for credential management. Using GMSA accounts instead of regular ones can also help improve security. Enabling Credential Guard is another strong defense, as it isolates secrets and makes it harder for attackers to access credentials. Monitoring logs continuously gives us visibility into suspicious activities and helps us respond quickly. And finally, following this identity hardening checklist ensures that we're covering all bases to strengthen our overall security posture. Remember, each of these steps connects back to our overarching goal: minimizing risk and protecting our assets effectively.